Hello, everybody. Welcome back to Spring One. And I am so excited for our next talk. It is on a Spring Data's Guide to Persistence. It is brought to you by Strobl. Christoph Strobl. Take off, Christoph.
All right. Thank you, Glenn, and welcome. Happy you made it to this session on Spring Data and our guide to persistence. My name is, as Glenn already mentioned, Christoph Strobl. I'm an engineer on the Spring Data team working for VMware. But I think that's about enough on my person, because this session is all about you and how Spring Data can help you with your everyday data access tasks. Well, actually, it's also a bit about lawyers, because here's the safe harbor statement, which actually tells you that this presentation may or may not contain forward-looking information that may happen either not or in a different way. Still, Spring Data has been around for over 10 years by now, so the chances are pretty low that I hit one of those. And so, first of all, don't panic. This is an introduction session. So if you're new to programming at all, that's perfectly fine. Stick around, it's fun most of the time, actually. You know a little about SQL, not too much about NoSQL, maybe? Well, don't be afraid, it's not too hard once you get the differences. And if you're new to Spring or the Spring portfolio projects like the Spring Data one, great choice. Stick around. Spring can help you in many different ways. In this session, we'll actually be looking at a little bit of SQL, mainly with the Java Persistence API on top of it, but we are also having a look at the NoSQL store, in this case, MongoDB, which is a document database and pretty easy to understand. If you now feel, oh, damn, I picked the wrong session. Hey, there's lots of great content going on right now. So maybe you want to watch the Advanced Spring Tech track and see Sebastian talk about the latest innovations in CRUD native and how to run Spring applications there. Having that said, for all that remain on this track, buckle up, we're about to go. And we're going to go start easy with a simple database request that will load everything basically from a database table, a relational database table, where we match a certain criteria, a certain column against a variable. So this is actually plain SQL, as you can see it out there written a lot. And Java provides a lot of abstraction for accessing relational databases. And as I told before, one of those being JPA, the Java Persistence API, which looks pretty similar to the native SQL statement that we see in the line above. So the difference here is that we can use our Java entities instead of the column names to refer to columns, and that we can use name placeholders and whatnot. Of course, the Java Persistence API also comes with the criteria API that lets you express the entire statement in Java code. But for the sake of the space left on the slide, we're going to have a look at another abstraction, and this one is called Juke. Juke provides you with a fluent API that feels rather natural to the Java developer, and still comes with a lot of capabilities, even advanced ones, when interacting with relational databases. So when you look at the statements, you can see they all look pretty much the same. You have the select statement, then you select something from a specific table, and this all feels very common. So once you know a little bit about SQL and how to handle this, you might be already able to write code with the Java Persistence API or even use Juke. But what about the vast space of NoSQL technologies that we see out there on a daily basis? Well, things look different there. So let's have a look at maybe a NoSQL store. In this case, a document store like MongoDB. And the query that you see there looks pretty different from what we saw above. And it's pretty much the same if you look at, let's say, a graph database like Neo4j and the Cypher query that expresses the select statement that we saw before. Or to give you another example, it may even look different for a search engine like Elasticsearch, where you have a query that match and a match clause. So you see, there is while it's pretty consistent in the SQL world, when it comes to NoSQL, things can start to look different. Though there are stores like Cassandra out there, or even Apache Geode, that will come with a very SQL-like query language. But how do things look like when using Spring Data? Since I told you we're talking about how to make your everyday tasks easier, like accessing an employee database, an employee table, and getting information from there. Well, this is what it looks like in Spring Data. It's a single method that follows a readable pattern. Let's say, find by first name and give me a list of employees. And this works across a variety of stores. We have implementations for JPA, JDBC, Redis, Neo4j, and a lot more. Some of those projects are maintained by the Spring Data team itself here at VMware, like the ones about JPA, JDBC, Redis, MongoDB, and so on. And there are others that are maintained by the database vendors themselves, like the Neo4j module, or some are maintained by the community themselves, like the Elasticsearch module. Still, Spring Data isn't the answer to everything. It is definitely not a silver bullet. So you still have to know what you're doing. You might be missing an index within your database, which results in bad performance. Well, this is something that we can't do for you. There are means for you to provide us with hints that we then apply to get the query faster, but the root cause analysis is up to you. Spring Data is also not a magical tool, as we'll see in the session. It consists of proxies and default implementations for each and every store, and nothing magical in there. And Spring Data is definitely not one API to rule all the data stores. And during the course of this presentation, you'll learn why this is so. But what Spring Data is an API that provides you with a familiar and consistent programming model that respects the source-specific traits. And what we do mean by that is that we give you something that's called a repository, which is an abstraction over the data store, that operates on an aggregate root, which you can think of as an entry point or something your domain experts would call an entity. So this repository really lets you access data within a bounded context. And this helps you to have explicit boundaries in your application domain, and it helps you organize your domain. And the good thing about this is that once you've seen a repository and understand how the repository concept works, it's pretty easy to find your way around switching from one store to the other. So if you're familiar with the JPA repository, you might also already know pretty much about what a MongoDB repository could look like. And the finder methods would pretty much look the same. Still, we don't take anything away from you. So once you decide to use Spring Data, you'll always have access to the underlying technologies. So you'll always have access to, in JPA, let's say the entity manager, and you can still use that one. Or in MongoDB, you can still use the driver directly or indirectly, just as you want. Having that said, let's dive a bit into the basics of a Spring Data module and how it's organized. To do so, we'll have a little look at the anatomy of a Spring Data module. And on the top level, there's the thing that I've been talking about. There is a repository interface, and that's actually the place where you define your finder methods, defined by first name method that we saw before. And this repository implementation interface sits upon a default implementation. And the default implementation typically, in the case of JPA, uses the entity manager to perform operations. Or for most of the NoSQL stores and modules that we support, it sits upon a template API, which takes care of all the resource and transaction management that you might have to take on when running your application. The template API is typically using something called a mapping layer, which is the one component that is responsible for converting your domain entities into something that the store understands and that can be sent to the store via the driver. And for some specific properties, let's say enums that might not be understood by the driver themselves, there is a conversion engine that lets you translate specific types or even entire entities into a store native format. All of this sits, of course, on top of the database driver, and that does all the heavy lifting. So let's have a little look at the template APIs. I chose the Mongo template since we were talking about MongoDB as our NoSQL store of choice in this presentation. And the template is held pretty close to what the actual driver can do. But remember, it still takes care of all the resource management. So you don't have to return a connection to, let's say, a connection pool after you're done with running your query. And the template gives you, of course, access to all the functionality that you might want to use, let's say, for running queries against the database or adding and removing stuff there. Queries are actually, most of the data stores and module implementations come with their own query API that lets you define lookup operations in a fluent way that is kept close to what the store can actually do. And you always have access to the underlying functions that the store gives you or the driver gives you, while still having the benefit of transaction and resource management. And this is done typically via an execute method. In this case, it does a lookup within a collection in MongoDB and loads the data into an array list. So you see, we never take anything away from you. You still can use native driver capabilities if you want to. We're just adding a little bit on top to make things easier and not having you to deal with all the resource management on a daily basis. The repository itself is, as said before, just an interface. It's a declaration, it's a contract, and it's defined of the domain entity and its ID type, just for having typed methods in there. And what you can typically do is you can extend the interface by one of our marker interfaces, which is a repository. The repository interface that Spring Data provides itself doesn't have any methods. So with a repository declaration like this, you wouldn't be able to do anything despite adding custom finder methods, which we'll see in a second. But there are other interface declarations that you can extend from, one of them being CRUD repository that gives you all, of course, CRUD operations. Let's say find, delete, update. You'll also find all and by ID methods there. And we got another abstraction, which is called the paging and sorting repository that adds specific methods to the repository that allows you to page through a result set. So what this means is you have a page abstraction that gives you a certain amount of data typically defined by a limit and an offset to read from the database. And it also has a convenient API to tell you how many results are there in total. So it will also perform a count operation and tell you, hey, let's say we got 5,000 employees and you're looking at the range from 100 to 200 if you load 100 employees at a time. All right. If you choose to go for, let's say, the plain repository implementation that doesn't have any methods in it, you can always pick and choose from the other repository interfaces and add those to your repository interface declaration. By doing so, you can limit the amount of data that you expose to the outside world and the consumer of your API. Let's say you want to have just a read-only repository and prevent users from adding data to it. Just don't expose the save and delete the CRUD operations and add just defined ones to your repository. As long as the signatures match one of the predefined repositories, the default implementation is actually totally fine with doing the work for you. The repository interface itself is at runtime, then covered by a proxy and backed with a store-specific default implementation that does all the work for you, like invoking the execution of the driver. And it will also detect methods that are not covered by the default implementation. And those are the so-called derived finder methods, like the one that we saw before. And it will figure out, hey, I haven't seen this. This is actually not part of the CRUD repository or the paging and sorting repository. So wait, we're gonna have to split up the method name and inspect everything about that method to find out and determine what you actually want to do and which data you are interested in. And the way this works is we are looking at the return type. So in this case, we find the list. The list tells us, hey, this is a collection invocation, and we're going to fetch a huge amount of data, everything that matches the criteria. Then we are looking at the operation keyword, which tells us, oh, this is a find operation. So we are going to look up stuff in the store. And by using one of the property names within the employee type, like an employee has a first name typically, we know that we need to match against one of those properties. And we do so by having a bind argument. Now, if we go back one slide, actually having such a method or running such a method and lookup on a large data set might bring you into trouble, because what happens there, since we're returning a list, is we're going to load everything, every single employee that matches the given criteria into the memory of your application. And this can put a lot of pressure on your memory and runtime, because you need, and your network, obviously, since you need to load all of those. So there is alternatives, like the page that we talked about before. The page is, as already said, a chunk of data that gives you a defined range of matching entities. It also gives you the total count, which will issue an additional query. So please keep in mind that this has a performance impact, like using a page. Though you're loading a small amount of data, an additional query will be run to determine the actual result size in total. Still, if you want to avoid this additional count query, you could use something like a slice. We have support for this as well. That one will actually avoid the total count and still tell you if there is more data available. However, even using a page can get you into trouble. If you think about deep pagination in large data sets, because every time you invoke this find method, a resource allocation happens. So we are going to get a connection to the database and then run the query. And depending on the offset, let's say you have a 50,000 rows and you then have to skip 49,000 rows on database side. This can put a lot of pressure on your database, not even on your application. So there might be a better option for those deep pagination problems. One could be, let's say, a stream execution. So this would let you operate on an open connection, just getting data one by one and not having to allocate resources every time. Still, please don't use a stream and then call skip or limit on the stream itself, because this would contradict what we are trying to achieve. And always make sure to close the stream properly, because this will tell us to release the bound resources and free memory on both application and server side. Now that we are done with the difference of paging and streaming and loading entire data sets, we can actually have a look at the derived fetch queries and the number of options that we provide there with Spring Data. So let's split this apart a little bit. First of all, you have a variety of choices of return types. We saw the list before and the page, and here you get the slice and the stream, but you can also request a single entity. And this will even error if there's more than one found, if you just wanted to have a single entity. Then it's followed by the find keyword, or one of the keywords that you would want to use, because you could use read, get, query, search, or stream, whatever you like, just for the sake to avoid clashes with other method signatures or your personal preference. This is followed by a placeholder. So you can put in there anything you like. Still, you don't have to. And the delimiter. So the by keyword tells us, hey, this is where the actual property matching will start. And from there on, we'll go and compare the input that we find there against your domain types. This one is followed by an optional match operator that tells us actually what to do with it, like a like query. And then you can order it if you want to via keywords. You can even get top results. Let's say there would be top 10. This would give you the top 10 results. So far, so good. This also works for, of course, count queries. The very same pattern, though I wouldn't recommend using sorting here. Doesn't make too much sense. And the exists query. So you can have the very same pattern with different keywords and different return types to achieve a different goal. So you don't have to look for one employee with the find query and then see, is it there or isn't it? There are dedicated keywords for that. You also can have modifying or delete queries and to remove entities. Some data stores might need a little help from your side to tell the underlying implementation that you're about to change data within the data store, especially for JPA, this is true. So you have to add the add modifying keyword here. And then you can pick and choose from the return types. You could either get the full list of employees that got deleted by this query or removed, or you aren't interested in the result at all, you just want it to be done, then please go ahead and choose void, or even just get the number of entities deleted. In this case, we can serve you with that number as well. Please also keep in mind that depending on your choice, the runtime may be different, because it makes a difference if you're interested in the outcome of something or not. Wow, that was quite something to digest, I'd say. So there is a lot of options, and typically when you write the find method, you might not always have the exact properties names in your head all the time, or be aware of the keywords or delimiters or what have you. So it's pretty easy to mess up there, but pretty close to all modern IDEs have support built in for Spring Data repositories and can help you with auto completion once you're not sure if your actual query matches your domain types. And even if you happen to code in a text editor, if you like to, then at runtime, we'll always be there and check your domain model against the finder queries that you declared in the repository interface. And we'll do our best to give you even hints that point you into the right direction if you misspelled one of the properties by accident. Now, we've been talking about how to limit data exposure before with the repository by just exposing certain methods to the outside world, preventing users from actually executing insert operation or save operations. Still, you can, using Spring Data, also influence the amount of data that people see when invoking a specific methods by serving them views on the data that you have persisted. And there are several ways to do this. One of them would be something that we call DTO projections. And in this case, you define a class that matches the properties you want to expose to the outside world. And on execution, we'll figure out what you're interested in, and then only select the columns defined within the DTO or the fields defined in case of a document store defined in the DTO from the database. So we limit the amount of data that is transported over the network and then serve that to the outside world. So the user won't even be able to access the data that you don't want them to see. The same works for interfaces. So you could define just the get methods that you're interested in and serve and then return the interfaces. In this case, since this is something called a closed interface projection that doesn't have any dynamic elements in it, even in this case, we can derive the columns that you're interested in and pre-select only those from the database. And the most flexible way of doing this is using something called an open interface projection that is using expressions on the underlying target, which is the store native representation of the fetch results. So you could target a specific column and then concat the values there. In this case, since we don't look inside of your expression, we are unable to determine which fields to load and will just select everything for you. We also got something called query by example, which is actually a good fit for, let's say, web search forms where you have a predefined format. Let's say you want to look up employees and I got a search mask there and expose an employee to the actual mask. Then you can take that one, put it into an example as a probe, and then it will take the values that are non-null or depending on your configuration and match the entries within your data store against the given probe. We also got auditing support, just so you know. So you can, Spring Data can handle auditing for you and automatically fill creation and modify dates, or even add who changed an entity if you provide us with the information to do so, which is actually an implementation of auditorware, and Spring Security has already an implementation for that. So you just need to plug it in there and activate auditing, and everything will work out for you. And on creation or modification time, the values will get updated for your data store. A little bit of an advanced topic would be the reactive API that Spring Data comes with. So we got actual reactive repository implementations that could easily fill up a talk on its own. So the point I wanted to make here is that though the execution model between an imperative application and the reactive one is pretty different, still the interface that you're used to from the imperative world, like the repository, doesn't look that much different in the reactive world. So you still have the very same patterns here. The only difference that you can see on this level is that it returns a different type of flux, which is a reactor type that you can think of a constant stream of data. And if you happen to buy into reactive programming, please just don't forget to subscribe to the stream. Otherwise, nothing will happen in your application. So please mind that. All right, you made it this far. That's good. Now that we've seen the differences in the SQL and NoSQL world on the slides before with the different queries, this all comes down even to the storage and how data is organized within the data store. Obviously, otherwise we wouldn't need any different technologies. So what I wanted to do next is tell you a little bit about the differences from a relational database to, let's say, the document store, MongoDB, how data is organized, what the defaults are when it comes to linking or embedding data into other tables or even documents. All right. You remember the employee that we had throughout this presentation the entire time? Good. That employee now became a manager, or not became, got the manager assigned. Who'd have guessed that? And in the relational world, it would be potentially modeled like this. So you'd have a manager table that has the ID and the name of the manager, and you'd have an employee table also with the first and last name and the manager's ID that links, typically via a foreign key, the employee and manager entities. So you can tell from the employee which manager it's assigned to, and the other way around, just by joining the two tables together. Now, in this NoSQL world, and especially with a document store like MongoDB, things look entirely different, and the way you model data heavily influences what the result within in the store will look like. So if you go for the defaults, then this this scenario might look like this. So you'd have a containing document that would be the manager, and the manager could have potentially, depending on your choices, a list of employees that are directly embedded into the document. So things look really different. And this is one of the reasons I told you in the introduction that Spring Data is not one API to rule them all, because there are tremendous differences in data modeling and your choices, how you model data when it comes to store specifics and the store that you choose. So the point I want to make is that your domain, your choice, your data store choice influences potentially your domain model and the other way around, and that you should pick the store that fits your needs and not what you think to be cool or you have at hand. So make a wise decision and use the best tool for the job. And to emphasize this, let's have a look at the differences that you'll immediately see once you buy into a store. And we'll do so by comparing the employee entities and their implementations in JPA and MongoDB. So on the left, you'll see the JPA entity with all the annotations that come from the JavaX namespace, like the generated value for the ID. So you'd have a certain processor that gives you UUIDs on first insert. You'd potentially, your columns that your properties match to within the database have different names. So you'd have to add the add column annotation there. For MongoDB, it's not that much different. So you see the stores, though different in storage in the Java world, it's not that much of a difference. It has another annotation on top. Let's say it's a document, which identifies it as a MongoDB document. It's still, we have to identify the ID. And instead of columns, MongoDB is using fields or nested fields. So this is the add field annotation there that maps your property to the actual field name within the database. And it will not end there, because depending on your design choices, you can teach either store to behave differently. Like we saw, MongoDB by default embeds other elements within the root document or even lists of other elements. But you still can move to a different approach and follow the same strategy as you did with JPA by linking entities together, which might be beneficial for your application. Who knows? It really depends on what you're trying to do. And in this case, MongoDB has something called dbrefs, which is a native storage format that has a $ref that tells you in which collection you have to look up the entry and then the ID of the entry to look up. So in this case, you'd store within the manager document just references to other documents that potentially live in another collection. And you can do the same the other way around. And you don't even have to use the native format. Like Spring Data comes with something more simplified. Let's the document reference that lets you just store the ID of a referenced entity instead of a full-blown dbref object. This saves a little bit of space on the data storage side and is easier, potentially easier to read and use for humans and your application. The document reference is one of the features that will be part of the next Spring Data release, but it will likely look pretty much what I showed you here. For JPA, you also got the other option. Let's say you chose linking by default, but you want to embed stuff there. What you still can do is you can use the add embedded annotation to flatten out an entity into the actual table that you persist your domain type to. Still, you might have to use some attribute overrides to avoid name clashes there, since the manager might have an ID and so does the employee. So you have to have an attribute override and rename the manager's ID to something else, potentially. But you see, it's possible. With all of the stores, you can choose which way to go. It may just require a little bit of effort to get it done. And not only the storage format is different between the stores, but also the query language, as we saw in the introduction. It looks different for each and every store. That's why we have default implementations for those. And the actual query API might look a little bit different depending on the store you're using. So if you're using JPA, you might have access, or you will have access to something called store procedures, which is a piece of functionality that is stored inside your database that you can call via a dedicated name. And you typically assign it a namespace, and then it can have input and output parameters and whatnot. And the JPA module, therefore, offers you something called the add procedure annotation that you can add to one of your repository methods. You see, this is not a lookup method, but an add procedure method. So this way, we figure out you want to call a store procedure and do something, potentially increase the salary of someone, which is a nice thing to do anyway. But still, this functionality won't be around in other stores. Let's say in MongoDB, which offers limited capabilities of executing JavaScript functions, but those, I think, if I remember correctly, got deprecated already. So the MongoDB module won't offer you anything like an add procedure annotation at all. Instead, what you'll find there is capabilities for geospatial queries. And we get special types for those, let's say georesult, that holds the result list, including the distance from your target location, as well as the average distance for all the found documents to the target location. And you can still choose, if you're not interested in, let's say, the average distance, then just pick a list. If you're just interested in, hey, I want to find the office, all the VMware offices next to a given location, and then there you go. If it's stored in MongoDB, that shouldn't be a problem at all, since it works on an Earth-like sphere. It can tell you pretty easily where to go and get the results for you. Nevertheless, I always recommend that you read the reference documentation on the specific capabilities a Spring Data modules offers for a store. We got dedicated sections in our reference documentation for the store specifics. So on top, you'll find a common section, which is pretty much what I tell you in this session. So how do repositories work? How do find methods work? What is the reason behind all this? And then in the actual reference, you'll find the store specifics that tell you, hey, you need the driver in this version to make it work. This is how you set up your application context if you're not using Spring Boot and whatnot. So please go there, read it, and then if there's something missing, let us know. We are always happy to improve things around our documentation. Still, it might not be enough what we offer by default, or let's say method names can get complicated. Let's say you have something find by first name and last name and location year. And even if you have a widescreen monitor, at some point it won't be readable anymore. So you can always, each and every store has means to let you push queries to, let's say, a properties file, or even if you need to have you execute native queries, like in this case, you wouldn't be able to achieve that with a derived finder method. Let's say you wanted to select the manager and at the same time wanted to know how many employees does this manager actually have. Then you could express this via a native query in Spring Data JPA via the add query annotation, and we'd go pick that annotation and run the query for you. You could even put in placeholder values that will then map to binding arguments and whatnot. So there's plenty of options there. Still, if you switch to another store, let's say MongoDB, the document store with the different storage model. Remember, employees by default didn't get just linked to the manager, but the manager document itself holds an array of either DB refs of the employee itself, the entire document, or even just the ID value of the employees. It's different there. So you don't need to have the join, and MongoDB can't even handle joins right now, despite the lookup aggregation function. But still, you could use something called the aggregation framework in MongoDB, and then just select the size of the array that is stored within the document to achieve the very same outcome. You see, it behaves differently there, and that's why you have to pick your store carefully and can't use Spring Data to just swap out stores underneath your implementation. If this is still not enough and you need further customizations, because what you're trying to do is so unique to your company or your requirement, then you can add custom implementations to the repository itself so that you keep everything that a Spring Data repository offers you and then add that bit of functionality that you can't express via the API as it is. So you remember the slide from before, this is what repositories look like. And you can then add interfaces and we call those interfaces fragments that declare the method signature next to the repository and provide an implementation and extend the fragment within the repository interface. And at application startup time, we are going to look for those fragments, anti-fragment implementations, and hide those behind the repository proxy and invoke the method for you so that you don't have to worry about it and still expose this centralized access, the repository, to your API customers. So time flies, especially when you're having fun. Still, there might be the day that you run into problems with your queries, and you have to troubleshoot those. The advice I can give you from our perspective is that, first of all, keep calm. This happens to everyone. Everyone has dealt with bad performance in the one or the other way in his career. So there is nothing to fear. There's plenty of options that you have. One of those being repository metrics. So the Spring Data repositories come with internal metrics that you can either print out or access via an endpoint in Spring Boot that can tell you for each and every repository method invocation how long it took from receiving to actually returning the result. We write a lot, really a lot of logging information. So if you enable debug log, you'll see the queries that we run and mapping information and whatnot. So you can always have a look there to figure out, hey, wait, this query, this direct query, that one doesn't look good. You can also have a look at the network statistics. It did not only happen once that a bad switch caused performance troubles. So it might be that one. Look there and maybe you'll find the cause. And always, please always use the query planners of your data store. They can tell you if a hint was applied correctly, if an index was used, if potentially an index is missing. Go check out those, find the missing spot, and then add maybe just an annotation to your query method. Let's say add hint and then provided the index name, and there you go. Performance is back up. All right. We're getting close. There is just a bit that I want to show you. There is lots of resources out there when it comes to Spring Data and the specific data stores. One of those being the Spring guides themselves. Just go to the search box, type in data, and you'll find plenty of resources, guided tours, how to set up stuff for, I think, all of the stores, Spring Data REST on top of it and whatnot. So this should get you going pretty fast. And we also got a GitHub repository that hosts tons of store-specific examples, let's say for streaming data from a collection and whatnot. So please go there, check out the samples. You should be able to just clone the repository and run it, because most of the samples already use test containers. So you should be pretty good to go if you get Docker installed. And with that, I wanted to point you to the session from one of my colleagues, Greg, that is coming up in, I think, about half an hour. He's gonna live demo the stuff that I showed you in this presentation and the more advanced topics like mapping, auditing, transactions, or even entity callbacks in a live demo. So make sure to check this out if you're interested in more things Spring Data. And with that, I wanted to thank you for your time. I hope you enjoyed the presentation and have fun at the rest of the conference. See ya.
Christoph, thank you so much for that presentation. I just keep forgetting how much is in Spring Data and how much time it saves us, but yet, again, giving us that consistent model, but allowing us just to get right to the details of each of the data store's specific strength. So thank you for that presentation. With that, folks, feel free to join Christoph in the Zoom session. You can take a look at your Slack channel, and it should have a link to the Zoom session if you want to go and ask him additional questions, because, again, he covered a lot of material, and it's very valuable. So in our next talk, we're going to be learning RSocket using RSC. It's going to be presented by Toshiaki Maki, and that's going to be at 11:05 Eastern Standard. So I look forward to seeing you then.